Welcome to this lecture in design patterns, where we will give an example of the strategy design pattern. The scenario is a simple duck simulator, and our duck simulator relies on a main class where we create a few different ducks and we display them by using the common display method. So we've used the common object-oriented technique of providing a base class with functionality that is common to several subclasses. In this case, we have an abstract class duck. And it features a display method, simply describing that every duck is a, and then based on the description or its name, we describe it as a maladuck or a red duck. So a test run of this application will look like this. This is a maladuck, this is a red duck. Okay. There are several ways in which we might want to change this initial design. We might want to introduce more behavior so that all ducks can swim. Sorry about that. And we can use our name method again. And since all our subclasses inherit from duck, all receive this functionality for free. But how about adding a new class, a new subclass? We want not only maladucks, red ducks, but maybe we want rubber ducks. And this rubber duck would simply be described like any other. But maybe we wouldn't want it to go swimming. Okay, so we've encountered a situation in which one of the subclasses should have a behavior that differs from the others. We've seen two types of changes being introduced. The first type of change was that we add a functionality in our base class, which affects all subclasses. And that was alright as long as all subclasses were supposed to have a swim method. But in the case of our rubber duck, we'll have to ensure here that our rubber duck doesn't do what the super class says, but rather says that he can't swim. But assume now that we have a number of different subclasses, and we add functionality to our base class, and it looks like all the other examples. But of course, if we change the base class, this change will affect our rubber duck as well. So for each change in our base class, we'll have to ensure that that is the desired behavior for all our subclasses. And for our fellow rubber duck, if we add methods to describe how he swims, flies, or quacks, every such method will have to be overloaded as appropriate in our rubber duck class. And we might add other classes that should inherit some, but not all, of the base class methods. So how should we solve this problem where there is common functionality for a certain subset of our ducks, but not all. We use something called strategy. We separate out that which changes, the behavior related to flying and swimming in this case, and we make sure that that which is common to both the mallard duck and the red duck can be shared, but does not have to be shared by inheritance to all subclasses. We do this by delegating swimming and flying behavior to an object responsible for taking care of that aspect. So, we have a swim behavior that contains a method for swim. And this swim behavior would of course have to be a field. It's actually not a duck, but it's a swim behavior. Swim behavior is not defined. Let's define it as an interface so that several classes can implement this in respect of their base class. And in this interface, we have to go back to our duck class to see that it needs to contain a swim method, like so. Now we can create a default swim behavior that can be shared among those ducks who are normal ducks in the sense that they can swim. So we override this swim method by stating that the duck which has this behavior is swimming. So there has to be a reference to the duck which has this behavior, and that can be provided with the default constructor. So in our default constructor, which takes a duck d as a parameter, we can instantiate a field called duck. Okay, so now we have access to a duck, and in the swim behavior we say that the duck is swimming, and we can invoke the swim method. So in our mallard duck class name, we could say that the default behavior for all ducks so in our constructor, the default behavior is to say that the swim behavior should be a new default swim behavior. But we could also provide another behavior. So it's a class, what is it? No swim. Or maybe we should say that for rubber ducks it's a floating behavior. Like so. So our swim implementation would be very similar to this one, but we simply state that it's floating duck. Okay, so our rubber duck class, instead of overloading swim, we could say that when we create this rubber duck, we say that the swim, yeah, we need to expose the swim behavior from the duck class. So instead of having it private, we say that it's private, but with some getters and setters. Now, in our rubber duck, we can set the swim behavior to a new floating swim behavior. Like so. And our example now will state that the rubber duck is floating instead of swimming. However, it's also flying, so in order for this to be complete, we'd have to ensure that the fly method is extracted to a separate delegate object instead of the duck. So we could say that there is a fly behavior where we can invoke the fly method. And maybe we could call it something else, just to be clear that this is another object. So we create this field. We'll say that it's a fly behavior. Create this as an interface. And the invoke fly method will, of course, be necessary in the fly behavior. So now we can create a class, default fly behavior, and this implements our fly behavior. Invoke fly means that we use some reference to the duck and state that it's flying. Okay, so if we move to our duck class, we'll have to ensure that we can modify this fly behavior in our rubber duck. So make sure that there are getters and setters. And actually we can create this new fly behavior in line if we will. If we want. And simply state that the rubber duck is on the ground. Oops, what happens here? Well, if we go to our duck, of course we'll have to ensure that all standard mallard ducks and red ducks have a default behavior. So fly behavior is a default fly behavior. And our rubber duck is now defined so that it's floating, it's not flying, and it's a rubber duck. And by having the default constructor in our duck class state that there are several behaviors that we attach to this duck. And not only can we say that these are the behaviors for all standard ducks, but we can also change these behaviors at runtime. So, for the first duck, we can change the fly behavior. So that the first duck is no longer able to fly. And then we try to fly with him again. You can see that the first duck is too tired, but the mellow duck. But the red duck is flying and the rubber duck is not flying as before. So, with this delegation to external objects, we can ensure that this behavior is changeable at runtime, or we can also more easily accommodate changes in some classes while sharing the functionality that is common between MalloDuck and RedDuck. And now we'll have to make sure when we create ducks that we set the appropriate behaviors for them.